Wait. Hello, is anybody there?
Hi. Hello.
Huh. Can anyone hear me?
Yes.
Let me see. Is my sound all the way down? Oh, my sound is all the way down. Okay. Now, can anyone hear me?
Yes.
Yay.
Yes.
Good, good. As long as one person can hear, that's good. Even if I have 40 students, as long as one person can hear, that's good. Okay, so I got everybody here. People are muting themselves. That's very nice of them. I can mute you all. Yeah, everyone's muting. That's fine. You don't have to mute. I mean, when we start, we'll mute. We'll start the meeting in earnest in a couple of minutes. Also, I want to tell you that this meeting is being recorded, and I will post a recording, either this meeting or the other meeting, whichever of the two is the best. I'll post the recording of that meeting. Are you guys, how many people here, like, let me see here, by raising your hand, how many people have done a Zoom before as a student? Hey, there's Ryan, yay. Jacob, you don't have to actually raise your hand.
Which one?
There's a little thingy you can press.
There is? Where?
On the bottom, if you put your little cursor at the bottom of the screen, then like a bunch of choices show up. And one of those choices, I think, is raise hand.
There's a thumbs up and a clap.
Yeah, oh, that's the clap. I don't know what the clap is for, but so Yu Ning raised her hand, Dominic raised her hand, Jacob raised his hand. I suspect Ryan is going to raise his hand soon. And we got some thumbs up.
Never done a Zoom.
Okay, good. And so Sumbal, you're still going to have to raise your hand at some point. I just want to see that you guys can figure that out. Like I said, put the cursor at the bottom and all your choices will magically appear.
There's also a chat. That's cool.
Yeah, you can chat. I think you can chat with me, but don't try to chat with me because that's just too complicated. I can't like talk and chat like clicky clacky simultaneously.
Because you can send out, it looks like you can send out things to everyone or to just like an individual person. So that's cool.
Oh, good. Okay, so if you have a friend who's here, you can like chat with them while we're doing our thing. That'll be great. Cool. Yeah, so that's Jacob Azurin. Cool. And, which Jacob is this? I've got another Jacob.
I just joined in twice.
Oh, great. That's great, Jacob. Don't confuse me or anything. Okay, well, hey kids, it's 10:03 and let's get started. And I'm just using this as a time to oh, go ahead and, oh, wait. Do I get to make all your hands go down? How do I do that more? Here, just a second. Allow participants to unmute themselves. Yeah, I've allowed you to unmute yourselves. Lower all hands. Boop. Okay. Well, you guys all lowered your hands without me having to do it, but yeah. So I guess my first question is: does anyone have any questions or issues on any of the assignments? I assigned assignments 34, 35, and 36, and we haven't gone over any of them. Anybody
Are we gonna finish the light bulb demo or?
What happened? I haven't looked.
There was no fluorescent light bulb part.
Yeah, and you know what? That part's actually not that important, especially nowadays because there's no fluorescent light bulbs much anymore. Mostly it's LEDs. So don't worry about the fluorescent light bulb part. There's just one thing that was kind of interesting, but like I said, it's kind of obsolete now because there's no fluorescent lights. So don't worry about that. So we're good. You're good on the light bulb demo. So Does anyone have any question, any particular problems you want to go through?
I like underlined the ones I had to ask about.
Okay, and this is Ryan, right?
Yes, this is Ryan.
Hey, give me one. Let's start doing problems together.
What was it? Assignment 35,
Uh-huh.
number 65.
Number 65. Okay, let me look at that one.
I should probably grab my textbook so I can see what the question was.
Oh yeah, yeah. See, I've got my textbook on the the vital source bookshelf thing. I didn't bring the textbook home.
I got my physical copy.
Okay, and I hope everyone's paying attention. Let me write this. Let me do this right now. In just 1 second. I'm actually drawing the schematic, and then I'm going to talk about it momentarily. In my opinion, the biggest thing you guys need is to be able to tell when resistors are in series, when they're in parallel, and when they're in neither. Because a lot of times they'll draw resistors that they look parallel to each other, but they're not actually in parallel. I'll try not to talk too loud. When I'm on the cell phone, I tend to talk too loud. Oops.
Yeah, I couldn't figure out what was parallel and what was series, and I was like, oh no.
Yeah, and I got to tell you, us not meeting, there's no way I expect you guys to be able to do this, on your own without guidance from me. So here, let me do this thing here. I'm going to share screen with my iPad. Second here. I'm accessing the a plugin is required to share. What do you mean a plugin? I had it already. Technology sucks. Screen sharing has failed to start. Okay. Let's try that again. I was doing this just yesterday, Wait, what's going on here? Just a second. I practiced this yesterday. This is gonna suck. Okay, let me get out of this and try it again. And let me get out of this. Okay, I'm gonna try it all over again. Screen share, iPhone, iPad, share. Screen sharing has failed to start. Please try again later. What the heck does that mean? Please try again later. What? Okay, unfortunately, I'm a little dead in the water if I can't do the screen sharing, because what I was doing is I was going to do the problem and take the photo with my iPad. Here, I'm gonna turn my iPad off and then turn it on again. Boy, this sucks. Okay, just a second. I don't even know how to turn this stupid thing off. Just a second. Okay, here we go. Okay, so Ryan, are you looking at the schematic?
I am looking at the schematic.
Okay, so it looks like that sort of thing.
Yeah.
Okay. All right. Although it's weird on my screen, it's backwards. Does it look backwards to you?
No, that looks normal.
Oh my God, it looks backwards to me. So anyway, okay, looking at your schematic, okay, the 8 and 9 are definitely in parallel because they both have the same voltage. That is, one side of the 8 is attached to one side of the 9, the other side of the 8 is attached to the other side of the 9. So definitely
Okay.
the 8 and 9 are in parallel. So you can do your parallel resistance formula for the 8 and 9 and turn it into just like an 8 to the negative 1 plus 9 to the negative 1 quantity to the negative 1. You can turn it
Yeah.
into 4.23 ohms. So you okay with that, right?
Yeah.
Okay. And are you okay that the 4 and the 6 are definitely in a series? And
Yeah.
I need to say right now that the rule of thumb when you're doing simplification of circuits is to start as far away from the battery as possible. Or in this case, they call it just nodes A and B, which is what you would put on a battery. You start as far away from the battery as possible. So the 4 and the 6 are definitely in series because whatever current enters the 4 exits the 4, and that very same current enters and exits the 6. So right now you can turn the 4 and the 6 into a single 10, and I'm going to draw it now. You can turn the 9 and the 8 into a single 4.2, and I'll draw that now. And so just one second. So your circuit is going to look like that shows. Hey, can you see that okay?
Yeah.
Okay. So now do you see that the 4.2 and the 10 are in parallel?
Uh-huh.
It used to look like this, but then the parallel 8 and 9 I turned into 4.2, and the series 4 and 6 I turned into 10. And so now that it looks like that, now you can go ahead and do the 10 and the 4.2 in parallel. And I'm going to do that right now because again, the 4.2 and the 10 have the same voltage across them because one side of the 10 is attached to one side of the 4.2 and the other side of the 10 is attached to the other side of the 4.2. So now the 4.2 with the 10 in parallel gets me at 2.95 or approximately 3. So now this, and I'm just going to correct this circuit becomes just a 3 there. Okay, so the 10, let me see if I can. So do you see that the 10 and the 4.2 get crossed out and replaced by a single 3?
Mm-hmm.
And now you've got the 3 and the other 3 in series. So that makes
And
6.
those are in parallel with the 20?
No, actually not, because one side of the red 3 is not attached to the other side of the 20. So they're not in parallel. You can only be in parallel if you have the same voltage, and that can only happen if I'm holding your right hand with my left hand and holding your left hand with my right hand. That's the only way we get to be in parallel. And
Okay.
the red 3 isn't touching, one side of the red 3 isn't touching the 20. So they're not holding hands. So, but the 3 and the black 3 and the red 3 are in series because whatever current enters and exits the black 3 has to enter and exit the red 3.
Yeah.
That makes 6. So now, that those 2 3s become 6. And now you've got the 6. You've got the 6 in parallel with the 20. And then you can just do your parallel resistor formula to get that. And I got
Okay.
negative 1 plus 20, the negative 1 to the negative 1. And that gets me 4.6. So I get an equivalent resistance of 4.6. So is that okay, Ryan, and everybody else?
Yes.
Yay. Okay. Wow, I really would like to know why it's not allowing me to share my iPad. That's just really freaky. Oh. Oh well. Well, anyway, I'll just do my best. So is there any other questions? Well, we'll just essentially just go through whatever you guys want. And yeah. Anybody else have any questions? You can either raise your hand or just talk.
For number assignment it's not 30. Yeah, assignment 36 for number 69. Do you want us to like draw the schematic for each one, or can we like have like this different orientations and then like put different numbers with it? Like,
Actually, I would want you to draw a schematic for each and every one, like demonstrate that you know which each one is. Yeah. So, of course, the first one is like 6, right? So you would draw the
Yeah.
3 of them in series, and there's your 6, and so on. Just draw each and every one, because actually, what 69 is an exercise in drill. To make sure you can really quickly see series and parallel resistances. Yeah. Were you able to get all 8?
yeah.
Yay. Okay. Hey, anybody else have any other questions or issues? Hey, let's just keep going. We'll do this for another 45 minutes.
Can you
Let's
do number
see.
55 on page number 34?
55 on number 55. Okay, and that's Adam.
Yeah.
Yay. Okay, 55. 2 resistors, 42 and 64 ohms, are connected in parallel. The current through the 64 ohm resistor is 3 amps. Determine the current in the other resistor, and then what is the total power? Okay, so Adam, the fact that they're in parallel, do you get that that means that whatever voltage one guy has, the other guy must
Yeah.
have? Is that you sneezing?
That was me.
No, I think that's somebody.
so Adam, so here I'm gonna, and I really would recommend drawing a schematic, even for something as incredibly simple as, when I say simple, I mean incredibly uncomplicated as 55. So I've got the 42 ohms, and I've got the 64 ohms, and I've got 3 amps going through the 64 ohm. So we're looking at that, right? You able to see that okay? And so
Yeah.
since 3 amps is going through 64, by Ohm's law, the voltage drop across the 64 is 192 volts, right? V equals IR. So if the 64 has 192 volts, so must the 42.
Oh, okay.
So since the 42 has 194 volts, now you can do V equals IR again and get the current through the 42. And then,
Okay. Well, yeah.
okay, now the interesting thing is, once you've done that, they want to know the power, and there ends up being multiple ways for you to get the power. One way would be to do power equals IV. You can get the total current going into the circuit, which is 3 amps plus whatever you got for part A. That's the total current in the circuit. And then the voltage is 192 volts. So you can just do 192 times that total current. That's
Okay.
one way to get the power. Another way to get the power is to go, hey, I know the voltage is 192, and I can get the equivalent parallel resistance, which is a 42 in parallel with a 64. And so here, 42 in parallel with 64 is an equivalent resistance of 25.4. And so you can do power equals V squared over R, which is going to be 192 volts squared over 25.4 ohms, right? And that would be another way. You don't have to do power equals IV. You could do power equals V squared over R, and then do it that way. And also, the other power equation is I squared R, and you could do it that way as well. Do I squared, find the total current, and multiply by the equivalent parallel resistance. So what's beautiful about 55 is there's all these different ways to do it. Hey, so is that good with you, Adam?
Yeah. Thank
Yeah,
you.
you're welcome. Hey, any other questions or issues?
First, homework 34 for number 52B for the voltage. Can we just say it's 24 volts because they're in series? I mean, they're parallel. Sorry, because they're
Yes,
parallel.
absolutely. And in fact, I even give you a problem like that on one of your exams where I ask all this complicated stuff, and then like part C or D says, what's the voltage? And it turns out the voltage is just what you said, just whatever the voltage of the battery is. Yeah, so it's a big fake out. Yeah, good for you. Any other questions or issues? on any homeworks or any questions on anything conceptually? Boy,
I was going to say 117, but now that you explained that other one to me, I could probably figure it out.
okay, let me look at
'Cause I was having
117.
the same problem, not knowing which one was like in parallel or series, but I could probably figure it out now.
Oh yeah, 17 is an extremely complex problem, but I hope you see that the 8 and the 16 and the 9 and the 18 are definitely in parallel. And then
Yeah.
once you get that, what makes number 117 tricky is actually the best way to do number 117 is like a Sudoku. Is that how to pronounce it? Sudoku or Sudoku?
I think it's Sudoku.
Is it
Oh, man.
Sudoku? Okay. You do it like a Sudoku problem where you've got 0.5 amps going through the 8 ohm. So you get that voltage. That's the same voltage as the 16 ohm. Then whatever current those two guys are getting, all of that current goes through the 20 ohm. So you get the voltage of the 20 ohm, which gets you the voltage of the battery. You know what I mean? So you end up just kind of hopscotching your way through that circuit. You know, you're not well served by getting the equivalent resistance of the entire circuit. You're better just hopscotching throughout the circuit of number 117.
Oh, okay. So when I redo that, I'll try it that way then.
Yeah, exactly. So that's again, the importance of drawing a good schematic and then working with the schematic. Any other questions or issues?
Mr. Shana,
Yes, Dominic.
can you explain the parallel in the series, like the connecting hands thing, like the analogy?
Yeah, absolutely. So imagine everyone in the class decided to form a circle and hold hands so that I'm holding one person with my left hand and a different person with my right hand, and everybody's holding hands. And then imagine instead of kumbaya, we decided to apply an incredibly powerful electric shock to one person's hand. And you know, that shock would essentially go around the entire class and everyone would feel the shock. Okay, that's being in series, where holding hands, your left hand holds the right hand of one person, your right hand holds the left hand of another person, and whatever shock one person gets, everyone gets. You know, that's series wiring. So again, you know, if, you know, whatever current one person gets, everyone gets. Whereas parallel would be I'm holding my left hand holds your right hand and my right hand holds your left hand, and now the two of us are in parallel and we can dance, you know. And if a third person wanted to dance with us, then that third person would have to get like behind me and grab his, you know, with his left hand, he'd have to grab my left hand and your right hand. And with his right hand, he'd have to grab my right hand and your left hand. And now the three of us are in parallel. And then we could dance and do whatever we wanted to do as a trio, you know. I don't know, Dominic,
Thank you.
is that what you're asking?
Yeah, that makes more sense. Thank you.
You're welcome. Yeah, it's kind of, I have to say, this, you know, doing this meeting has suddenly become much, much harder because Zoom is not allowing me to do screen share, you know. That's like very, very frustrating. Yeah. Okay, any other questions or issues? So is everyone doing their homeworks okay? Everyone understanding it then?
For the most part, yeah.
Yeah. Yeah, because that's essentially what this session is going to do is replace what we would normally do in class as we go over homework. Well then, how about the light bulb demo? I'm looking at the handout, the light bulb demo handout. Here, just a second. Alrighty. So you guys good on that? This idea of the voltage drop, you know, why the parallel bulbs were bright and why the series bulbs were dimmer. You guys are okay on all of that?
Oh, could you explain why the 200-watt light bulb was like super dim when they were in series? I think it was.
Yeah, I can do that right now. Okay. So here's the thing. Your 200-watt bulb is attached across a 120 volt source, correct? And so since power equals IV, or power equals V squared over R, I'm going to use power equals V squared over R. So I've got 200 watts has to equal 120 volts squared over R. That is, and again, I have to show this to my camera because my stupid screen
Yeah.
share isn't working. So that's
Okay.
what we've got, right? So
Yeah.
when I solve for R, I get 120 squared divided by 200. I get 72. The resistance of my what do you call 200 watt bulb is only 72 ohms. It's a really low resistance. And we know that if it's going to be brighter, if it's going to give more power, and
There's
yet,
more resistance.
yeah, well, if it's going to give more power, but have the same voltage as some bulb that gives less power, the only way a bulb can give more power with the same voltage is to have a lower resistance, because power is V squared over R.
Yeah.
And so this little teeny 72 ohm resistor in parallel ends up dissipating a tremendous amount of power. But what happens if you put it in series with those other bulbs, which are 60 watt bulbs, right? So it was, what was it? 120 squared divided by 60. So those are 240, right? The 60 watt bulbs are 240 ohms. So when you put these guys in series, so that each one of them is getting the same current, not in parallel where they're getting the same voltage. So here, let me just do this. I'm making a drawing you would see if my screen share was working. But so here's what happens when I put my 200 watt in series. Now suddenly, since they're all getting the same current, the 200 watt, which is only 72 ohms, ends up having less power. Because power is now I squared R, they're getting the same current, but he's only got like about 1/3 of the resistance. And since power is I squared R and the 200 watt bulb only has 1/3 of the resistance, the 200 watt bulb is going to be so dim as to not even light, you know? Yeah. So and in fact, putting the 200 watt bulb in versus putting in a 60 watt bulb here in red, I'm gonna replace my 200 watt bulb with another 60 watt bulb in red. Do you see that when I put the third 60 watt bulb in, I reduce the current of the circuit because I'm increasing the equivalent resistance of the circuit. So I've increased the equivalent resistance of the circuit. I've reduced the current of the circuit. So now those 240 ohm bulbs have less power. They're dimmer. So yeah, with 360 watt bulbs in series, they're all dim. With 260 watts and a 200 watt, the 200 watt doesn't light, but the other 260 watts are actually brighter because there's less resistance in the circuit and so more current. I hope that's making sense.
Yeah, that makes more sense now.
Okay. I'm gonna have a drink of water. So let me think. Let me look through the light bulb demo, see if there's anything else I care, is important. Yeah, the calculations for part B, the calculations, I kind of showed you a lot of those. You get that weird situation where 360 watt bulbs in parallel dissipate 180 watts, but 360 watt bulbs in series only dissipate 20 watts. Which is interesting. I think it's 20. Yeah, it's 20. Oh. Anything else? Does anyone else have any other questions or issues about any particular homework problem? Yeah.
On the conceptual physics light bulb demo, are we going to be using fuses a lot in like tests?
No, the only question on a fuse on a test is that you know that the fuse has to be in series.
Okay.
so that when the fuse breaks, which means it creates an open circuit, then nothing else gets any current. So like with my light bulb demo thingy, I'm going to draw where the fuse would go in red. Here, just 1 second. The role of the fuse, a fuse is a sacrificial element where if the battery is putting out too much current, then the fuse burns out. Although nowadays we don't use fuses that burn out, we use fuses that, we use electromagnetic fuses that just switch off. But anyway, the fuse switches off, which means you introduce an open circuit where that red fuse is, and then nothing gets any current anymore. So yeah, all I'm going to ask is where does the fuse go, and you'll put it in series.
Okay.
Yeah. Anything else? Does anyone have any questions about the AP exam itself? Although you could all read that same article that I read, but does anyone have any questions on the AP exam itself?
So is it all F for Q?
No, you
'Cause,
know what?
what's it-
They haven't told us what it is yet, at least since I read about it like yesterday or the day before.
Because Trevor Packer, he like head of the AP, he like tweeted that it was all F for Q, but like it was never confirmed like in any of the posts or the emails.
Yeah, according to College Bowl, we're not going to know until April 3rd. April 3rd, they're going to put out another article that explicitly tells us the configuration of all the tests. However, these tests are going to be patterned after the emergency tests that they've given in the past. Sometimes you get, I don't know if you've read that article, but you get students who've experienced a natural disaster or experienced like some sort of man-made disaster, like a war or something like that. And then the AP for these types of students will give them a 45-minute online test. This is something they've done in the past. So, however these tests were configured in the past, there's a good bet that that's how they'll be configured this year. So maybe that Hewlett Packard guy knows. You said it was a Hewlett Packard guy?
Oh no, his name is Trevor Packer. He's like the
Trevor,
head of AP.
Trevor Packard, head of AP.
Yeah. Yeah.
Oh, well, I mean, if he's the head of AP and he says it, then I guess it's true. I thought they were going to wait till April 3rd. But yeah, whatever he
know.
says is going to go, evidently. But definitely, however they configured it for those past disaster victims, I would assume they'll do the same thing here. Which, if it's all FRQ, then that's what it's going to be. So for us, it'll probably be like two or three FRQ problems. Yeah, 3 FRQ problems.
Mm.
Yeah, that's going to be weird. So I just assumed it would be a mixture of FRQ and multiple choice. But
Yeah, I don't know.
And did you guys all get that I'm teaching you this stuff, the circuit stuff now, just because I want you to have a good AP physics class, but it turns out that they took it all. It's not going to be on the AP exam. So all the stuff you learned about electrical field and electrical force and DC circuits, Ohm's law, none of that is going to be on the AP exam. But like I said, I want you to have a good class, so that's why I'm teaching.
Mr. Shana, how's the test for chapter 20 gonna work, like from home?
Yeah, I'm gonna just email it to you on a PDF or whatever, and you'll do it, and you'll either scan and submit in the Google Classroom, or yeah, I mean it'll be just the same way you guys turn in homework. You'll just do the test, scan it, and admit it, and I'll trust that you guys aren't gonna work together on it.
All right.
So, yeah.
Thank you.
You're welcome. Yeah, a shout out goes for Nathan, Natalie, and Kyler. Try to resist the temptation to work together on this because they do everything together.
Are we supposed to be working on AP problems? I know you had a booklet for a Saturday, but
Yes, to prepare
we
for the
supposed to
AP exam, you're kind of on your own, but you should just start on page 1 and just start doing exams. Absolutely. Yeah, if
Are
you're
we
going
gonna
to
get any like AP review
Yeah, once we're done with the curriculum, we'll continue to have these Zoom sessions, and then those Zoom sessions will be just dedicated to AP review. Because actually there's only gonna be like, you only have like maybe two more lessons, 2 or 3 more YouTube videos to watch, and then that's it. We're done with the curriculum. And in years past, I would have you guys do a bunch of optics labs and Archimedes principle labs and things like that, but I don't get to do any of that stuff, which means when we complete chapter 20, we're done. And then after that, we're just preparing for the AP exam. So at that point, our little Zoom sessions will be just preparing for the AP exam. Mhm. Yeah. Jacob, why are you you're rotating yourself? It's weird.
I'm just like changing my background.
Oh, cool. Well, I get to choose a virtual background.
Yeah, I'm in Mr. Shana's class right
Oh, really? Here, let me look. Let me just look. There you go. Ah, that's pretty funny. Who's that guy? Yeah, I need to learn about this stuff. Video settings. Oh, touch up my appearance. What? How do I
now.
touch up my appearance? Can I make myself thinner? Oh, I don't know, man. Okay. Well, hey, kids, I mean, we don't have to be here for the entire hour. If we're done, we're done. Are you guys good? Yeah, if you have no more questions, then I'm just going to declare us done. Anybody have any more questions? Okay. Well, then, hey, I'm gonna declare us done, and then I'm gonna see if I can figure out how to fix this ridiculous inability to screen share. One participant can share at a time. Advanced share. So anyway, yeah. So you guys go ahead and leave. I'm gonna
Okay.
stay on for a little while because I'm gonna try to fix this screen share thing.
Real quick, do you have like a schedule of when we're gonna have like the Zoom meetings, or you're just gonna like email us and let us know, or?
Ryan, unfortunately, my own home situation, because we're on lockdown, ends up being like unpredictable a little bit,
Yeah.
especially like when my wife has to drive out to Palmdale to visit her mom, or when things happening with my kids or whatever. So to answer your question, I'm going to keep doing it the way I did. I'll tell you several days in advance, days and times.
Okay.
But it's not going to be a regular schedule. How many of your other teachers are doing these sorts of things?
Not many. No.
Okay, so I'm not having to like beef it out with a bunch of other teachers demanding you to do Zooming for several hours a day.
No.
Good. Well, that's good. Good for me. Okay, well, hey guys, see you later.
Bye,
Bye-bye.
Mr. Shane.
Yeah.
Thank you,
Bye.
Mr. Shana.
Thanks for
you.
coming, all of you. I really appreciate it. There you go. There's my key. Wow. Yay.